In this video, I'm gonna convert my all-electric UTV to be completely remote controlled with 3D printed parts. And then I'm gonna mount a snowplow on the front and plow my entire road without ever having to go outside. A robotically controlled full-size vehicle that I make myself. What could possibly go wrong? Ah! Oh, this is crazy!
Oh gosh, Riley!
What happened? This idea started last winter when I thought to myself, how cool would it be to plow my driveway from inside my house while I'm enjoying my morning coffee? It's not fast enough to be able to do a donut. With the help of my friend Alex, we set off to make a DIY remote control kit with off-the-shelf components. A few months later, and it's time to put these puzzle pieces together. This is a standard RC car steering servo. And this is our mega steering servo that's gonna let us turn the steering wheel of the UTV. This is a linear actuator that's gonna push on the brake pedal. And this is a linear actuator that's gonna push on the gas pedal. This is the brain that's gonna translate our inputs from this remote control to control these 3 parts. I think step 1 is just to plug everything in and see how it works. First things first, we're gonna need power. The controller is designed around 48 volts because that's what the UTV is.
That's not funny.
I thought it was funny. First, I'm gonna plug all the encoders in. Next up, brakes.
You need brakes?
That's what I told Alex. I was like, don't even bother. Why are we making the brake parts? Like, we don't need those. All we need is steering and gas. He disagreed. Throttle, which means it's time to power up the computer for the first time. Got an alligator clip on this one so I can quickly unplug it if I need to. It was just the inrush current. Okay, there's lights on. I think it's on. Oliver, are you as excited as I am right now? Here we go, last one, brakes. On. Okay, this is the throttle. Oh, I remember now. Alex added a kill switch. He said this switch has to be on for anything to work. Let's try again. Okay, ready? Hit the gas. Now the brakes, which would be backwards on the throttle. Alex made these in his garage with his 3D printer, and they work. Right?
Whoa.
Left. None of this was really specifically made for this vehicle. So the next step for this project is going to be figuring out how to mount all of these pieces so that they can physically push the gas, push the brakes, and turn the steering wheel. Let's get to fabricating. First things first, we need to figure out how to make this thing push on the brake pedal. The brakes are actually the most challenging part of this whole thing because they require a lot of force to push them to make the UTV stop. So to get the most leverage out of this system, we want to use the entire throw of this ram. Currently, when I measure the throw of the brake pedal, I get about 2 inches. This is 3 1/4. So we need to figure out a way to make this lever arm longer so that this actuator can get more leverage on the brake cylinder. .29. Got to fractions to decimals to, man, what if I just learned the metric system? That goes there to give us something solid to attach the rest of the stuff to. Next, we need to figure out a way to extend the brake pedal so that it's longer. It's currently 8 inches long and has 2 inches of travel. We need to have 3 1/4 inches of travel, which means we need to make it 13 inches long. What on earth? Windows error recovery. Try again. On, reset. Ha ha ha! Okay, we're back in business. I got a little carried away on this one. Are you filming me scrounging in my squirrel baskets? Hey, look, it pays off. Bolt, spacer, spacer, part, nut.
You're a nut.
Don't you start that.
You're a peanut.
A peanut? You're making me hungry. One brake pedal extension done. There we go. Okay, I don't know, does this fit? Yes, big enough. Washer.
Nice. Wow.
So now this is gonna go here, and even though this is angled like this, the actual arc is like that. So if we go slightly more than perpendicular, then as it travels down, it'll become perpendicular, which will give us more leverage at the end of its travel. We need to make a plate that matches this bolt pattern that goes on the bottom, and then come up with a way to come basically just like back to here. So I got these two tabs, they're gonna weld on like that to make a pivot point. And the other important thing is that our pivot point be in the center of the direction of force so that we don't side load this linear actuator. If the pivots were, say, off over here, then our force direction would be like this, and it would try to break this rod off 1.5 inches. Square enough for me. I've been dying to take these things apart to see what the insides look like. DC motor spins this gear, which turns this bolt, and then there are two nuts inside. So as that bolt turns, those nuts are threading or unthreading to push this rod in or out. Got a bearing inside there. Bam. Now we have a pivot point in line with our actuator. I think it's time to bolt the actuator into the car so we can start coming up with the next piece. I'm using this little sleeve bearing that I had laying around to put inside of here so that it's not plastic on metal where the pivot is. Okay, so now we need two arms that come, basically just two long tabs that come from here onto this. Go draw a part. Okay, brake bracket done. Time to cut the part out. I've probably cut over, I don't know, more than 100,000 parts on this machine. And every single time it is just as satisfying to go from like rudimentary tape measure and napkin sketch to a finished part. Here we go. Cutting out parts is only cool if the parts you cut work. Oh yeah, that's gonna be pretty much perfect. All right, now that we know that it fits, let's cut another one, weld it together, and the brakes will be done. One thing the Plasma isn't so great at is making perfectly round holes. So a lot of times I'll undersize my holes just a hair and then drill them out again because that gets us a much better round hole. Maybe I spoke too soon. There we go. A nice round hole. Bolt, spacer, spacer, part, nut. Welding inside of a plastic car to a part that is bolted to a plastic interior piece. What could possibly go wrong? Well, what do you guys think? Should we burn it in? I think it's time to test this thing. I'm kind of nervous.
Why do you feel nervous?
This is for real now. All right, I'm gonna plug in the encoder. Watch out for the spark. What do they say? Contact. Brake. We can plug in the power. Turn the remote on. Are you ready? Oh my gosh. It pushes the brake pedal. It can push the brake pedal the whole way. Like we have full actuation of the brakes. This is the one I was most nervous about because pushing the brakes requires the most amount of force of any of the other parts. I could just sit here and do this all day. Brakes, check. Which means that next is the throttle. So on the brakes, we had to extend the pivot point so that we could match this pedal travel to the throw of the actuator. But on the throttle, we already have 3¼ inches of travel, which means that this actuator is gonna sit something like that. I've got a plate cut out here that's gonna mount to the existing throttle pedal, but the throttle pedal has a little curve to it. So I'm gonna try to bend this plate to match the curve. Oh yeah, okay, that's good now. That's called not being patient enough to wait for the part to cool. Something happened in CAD though, and my holes are not at all aligned. Nothing like permanently modifying a nice new vehicle. Whoa! Oh yeah, that actually went really smooth. That welds like that. It's not about what is lined up, it's about what looks lined up. Yeah, I don't want to light my UTV on fire. And then we'll put a little heftier tack on the bottom because the force of the actuator is actually pushing this way on this bracket, so it wants to fold it up like that. Oh my gosh, Courtney. Do you want to do it?
No.
Are you sure?
I don't want to be responsible for this.
Brake. Oh my gosh, throttle. Ah! Oh my gosh, it's working. Throttle. Oh, you can definitely tell it's working harder to push the brake. It's working. Courtney, can we make the UTV move? Just like a little tiny bit.
What if it gets stuck?
The worst that happens is it runs over the wood stove, all of the fire comes out of the stove. Okay, UTV is on, reverse, low, 2-wheel drive. I'm gonna give it a little throttle. Ah!
Riley! Did you do that on purpose?
No, so I kind of panicked and I let go of the kill switch, so then the brake pedal didn't do anything. And then I remembered that I hit the kill switch when I hit the brakes and the brakes worked. Are you ready for forward? Here we go. It like takes a lot of gas before it starts going. There it goes, okay.
Brakes.
So it works, so throttle, brake. Woo! I would say that I'm a little bit shocked at how easily this is coming together. Like 3D printed parts, CNC plasma table, lots of creative ideas, an Arduino controller, and we're gonna have a remote control full-size UTV. I just looked up, looked outside, and it's absolutely nuking out there. This has been by far the strangest winter that we've experienced up here. It's freeze thaw constantly the whole time. We've gotten very little snow, lots and lots and lots of rain. Anyways, you guys have been asking a lot about the shallow well, so I thought I'd take you out here for an update. That's our shallow well right there. Apparently, when I backfilled the big hole, I didn't do a very good job of getting any compaction in it. And over the fall and this winter, all of this water has caused this area to basically be a sinkhole. And now we have a pond in our yard. All last summer, we were able to get a very small amount of water, but we were always able to get water out of this at about 1.5 to 2 gallons per hour. But all fall and winter now, the pipe's basically been full of water. So yeah, there's a lot of water, but check this out. Here's another problem. This is our underground cistern, and I guess I didn't backfill this hole all that well. It settled too. The electrical boxes where the wires come in that power the pump that's inside there, this actually rose above this box and filled our cistern with groundwater, with surface water. I dug this little trench to let this water out, so I stopped the problem, but this entire tank was completely filled with surface water. I think we're gonna have to build that filter system sooner rather than later. So very encouraging that I think we have an actual legitimate water source that'll supply our family with water, but also we're gonna have to do it sooner than we expected. Next up, steering. The UTV steering wheel turns 3 times lock to lock, and this servo is 8.5 turns from lock to lock. So there's a gear reduction here that we're gonna need to figure out. And the thing that I've come up with is to use roller chains and sprockets. We'll have a bigger sprocket on the steering wheel and a smaller sprocket on the steering servo, and that's gonna get us that gear reduction we need and provide the connection between the two. Well, that's easy. All we have to do now is figure out a way to mount a sprocket to that using these bolts. To get that same ratio of 3 turns lock to lock versus 8.5 turns lock to lock, I've settled on a 12-tooth sprocket for the servo and a 34-tooth sprocket in place of the steering wheel. And the thing that I think is about to just blow me away is the fact that I'm gonna download models from those sprockets off the internet, modify them to fit this funky spline on the servo and the bolt pattern where the steering wheel is, and then print them out and I can just attach them. Let's see if it works. Here we go. Okay. Just like that, we have a sprocket that is ready to send to the 3D printer that should theoretically just bolt into the UTV. Send. And we're printing our part. Okay, there you can see the bolt circle, the start to the sprocket coming around. Each one of those is a tooth. I literally cannot believe that I am printing a sprocket from a remote control UTV right here in the shop. And now I want to ask you, no cheating, no skipping ahead, what do you think? Drop it in the comments below. Is this plastic 3D printed sprocket going to be strong enough to support that metal roller chain and steer this UTV? Let me know in the comments. While we wait for those parts to 3D print, I also need to design a metal bracket that's gonna hold the steering servo in the right position. Zero my angle finder here, and then come to here, 71 degrees. To here, I already had it as 71. Oh my gosh, it's got like this much to go. Oh my goodness. I made a sprocket. A steering wheel sprocket. Do you think it fits the chain? Oh yeah. Yeah.
It fits perfect.
Fits perfect. Do you think it fits the steering wheel? Oh yeah, perfect. Let's bolt it in. Okay, we've got this second sprocket. This is the sprocket that's going to go on the steering servo. It's currently printing, and while we wait for it to print, I'm gonna get the rest of the steel brackets cut out and welded that we need to physically hold that steering servo into the UTV. I got all set up and ready to weld, and I almost welded it completely backwards. This goes the other way around. Now we're ready to weld. Now the question is, does it fit? Bingo! And then the question is, does it fit the chain? I think that means we're just a few tack welds away from testing the steering. Okay, that means is that hopefully my math and angles are right, and that when this is here, this is aligned like that. And all we have to do is tack it into place. I moved. Moved again. Ah, how about right there? Bam. So we want that link right there. There it goes. This is called a master link, and basically it's a piece of the chain link that we're able to disassemble so that we can take the chain apart. This little special C-clip then pops into these grooves. There we go. I think we probably need the chain tighter than that. This is gonna technically change the angles between the two, but also I think it's fine and it worked really well, so that's what we're gonna go with. Which means it's time to test the steering. Yeah, this is definitely the most exciting part for me. It's the most complicated part. It seems like it's the most difficult, most dangerous part.
Dangerous?
Well, yeah, like what if it doesn't steer right and it just drives off the edge of the road? Did you come down to watch it steer, buddy? Here we go, ready? All right, I'm gonna make it steer to the left first, which hopefully makes it steer left. Whoa! And then when I let go, it goes back to the middle. And then right, it's working. And then back to the middle. Courtney, it's working. The chain ride's smooth, nothing's binding. Whoa. Something is bound up in the steering and it's sticking. See that? It like hits a hard, it doesn't want to go past that point. Can you unplug that power, please? I can't let go of that. Wait, maybe I can just let go of the green button. Hold on, let's find out. Oh, no, okay. Thank you for undoing that. I'm not sure what happened, but the steering was bound up, which meant that if I let go of the controller with either of my hands, it was going to try to return back to zero, and I don't want to break the steering servos. Oh yeah, see, it's like, it's stuck because the key's off.
Oh my gosh.
It has a steering wheel lock just like a normal car. That was an unexpected, like, duh. That would never happen if we were driving it because the key would have to be on to drive it. So, okay, problem solved there. We hit the end of the servo before we hit the end of the travel of the wheels, which is exactly what we wanted because that means that basically the servo isn't trying to power through the mechanical stop at the end of the tire's turn. Okay, I'm gonna let go and just, this will be basically as fast as it can go.
Okay. Whoa!
Whoa! I had no idea what to expect. I had no idea if chain was the right choice for this, but I am so happy with the results that we're getting right now. Now we're gonna set it back down onto dry pavement, and now we're gonna find out if it can steer with the tires down on the pavement. Easily. We're able to get enough force out of that little motor to turn the wheels. It's amazing. We're almost ready to drive this thing, like for real. With the steering down, we can move on to the final step, which is that we need a way to switch this thing from forward to reverse and back to neutral again. On this UTV, this rocker switch controls the neutral, forward, and reverse. And our plan is to use this standard RC car servo to flip that switch. And yet again, we're gonna be turning to the 3D printer to make our imaginary parts reality. And this is actually kind of cool to look at. This is the actual print path. And so right now we can see the orange is all the outside layers. Each one of these is a bead of plastic getting printed down. The red is this top inside layer. Underneath that, you can just see the yellow, which is the layer below it. This one is going to take 16 minutes to print. And our part is done. Moment of truth. Does this little Pitman Army thingy fit? Oh, it is very close, but it's not quite right. Take 2 on this part, fresh off the printer. Now let's see if it fits. There we go. Our rocker is now installed to the servo. The idea here is that this is gonna set something like that. Next step is to make a mounting bracket that allows us to basically just screw this to the dash. All right, mounting bracket is done. This brings a whole new meaning to playing with Legos. I print my own Legos. I'm gonna use this double stick mounting tape. It's got a thickness to it, so it's gonna get me that extra space I need. Also, it means I'm not putting permanent holes in the dash of the UTV, which I wasn't too excited about. Before going any further, I changed the steering limits on channel number 5 all the way down to 10%. And then we'll keep turning it up until we're flipping the switch. That's gonna sort of keep me from accidentally breaking the servo. Okay, so I need to move the travel up. I have it at 10% right now. And so we're gonna go enter. I'm gonna turn it up to 20%. Try again. Okay, I think we need more travel. So I'm gonna increase it to 30. Okay, after some fine tuning and adjusting of the remote control controls, I think it's going now. So neutral and then, forward, that's perfect. Neutral, reverse. It's not perfect, but it's gonna work, I think, for our forward, backward. That's the last thing on the list, which means that it is time to test drive this thing. I think I'm just as excited as I am terrified, because this is the part where things become real. And what I made and what Alex made, we're about to find out if it works. What could possibly go wrong by zip tying the controller in? What do? You tap it twice and say, that's not going anywhere. I don't even have words right now. This is ridiculous.
I'm feeling optimistic, but I am running I think worst case scenarios through my head.
What's the worst case scenario?
That it goes forward, doesn't turn, and smashes into the building.
Okay, so worst case is not even that bad. I have brakes, now I'm just gonna blip the throttle. So throttle works, shifting it forward. Okay, it's working. I'm driving this thing remote control from outside the car. Okay, I'm hitting the brakes. I just hit the brakes, that's full brake. I haven't been this terrified and this excited in a long time. This is so cool. It's actually pretty easy to control. I thought the steering was gonna be way twitchy, but.
It's just driving down the road.
Goodbye. Brakes. I don't know, should we shift it into reverse? Theoretically now it's in reverse, so now it should go backwards. There it goes. Oh, it's a little squirrely backwards. That's not where the road was, Courtney. Oh man, I bet this can go places you can't even walk. Ah! Crazy driver. It is taking every ounce of restraint that I have to not just keep driving this thing around, but I think before we really put it to the test, I should probably weld everything and tighten the bolts. With the initial testing complete, and before we drive this thing anymore, we need to get everything wrapped up.
Ladies and gentlemen, attention please, about to start the show, better take your seats. It's been a while, but I'm back on top, to the world is mine, I don't plan to stop.
I'm gonna add this inline fuse on the positive side with a 20 amp fuse in it, so there's circuit protection on this thing, and then we're gonna add a switch so that we can turn it on and off from the outside of the UTV. I 3D printed a little switch holder that's gonna hold this rocker switch that's gonna let us turn that controller on and off. This is one of those boxes that is way heavier than it looks. Apparently there's an entire UTV snowplow in here. What is this, a plow for a bicycle? What do I do with the instructions? There are far more pieces than I was expecting. Woohoo! That's a lot of bolts. I think we're gonna need the instructions.
It says approximate assembly time 45 minutes.
Holy smokes. All right, challenge accepted. How we do on time? Yes! 8 seconds. Blah! Plow assembled, which I think just means that all we have to do now is mount it to the UTV. Aha! Yeah, I think it's good right there. Feeling strong?
No, but I do have appropriate footwear on.
Those are your safety slippers. Pretty funny, our first winter up here, all we wanted was for it to stop snowing. And now this winter, all we want is for it to snow. Woo! With the plow hooked up, all we need now is a little snow. This might just be the most ridiculous thing that Courtney and I have ever done. Here we go. Going forward. Woo! It's working!
If something goes really wrong, Riley, I just flip that switch from the outside. I think the worst case is it goes off that cliff over there. Okay. Oh my gosh.
Here we go. Ooh. Brakes. Oh yeah, I'm gonna go backwards now. Reverse. Oh, it's a little squirrely.
There's no one in that UTV.
What happened?
Oh my gosh.
Apparently I almost just hit the building. I have no idea because I can't see it.
Riley, you are like an inch from hitting the building.
Sorry. It's not funny.
Okay, you're clear of the building.
Alrighty, let's see. Tilt.
Bye!
Courtney, it's working! I have no idea how far we can drive it. This is crazy. It is so hard to drive it when it's driving towards you because everything is backwards. Don't crash it, don't crash it, don't crash it. Whoa, I'm gonna hit the camera! Ah! Oh, there's a car. I have an idea. What if I could control the UTV from inside the UTV? Oh God! Whoa, this is crazy. Ah! Whoa! Whoa, it's really hard to drive. Ah, it's working. Oh my God, this is the most fun I've ever had plowing in my life. Courtney, this is awesome. Are you sure you don't want to ride with me?
I'm not gonna wear my seatbelt because I feel like I need to be able to jump out.
I'd recommend that.
Oh my gosh. Oh my gosh. We're plowing snow. Woo. Woo. Oh gosh. Can I get out, please?
No, you don't have to get out. This is amazing. It didn't just work, it worked perfectly. I plowed the entire road. And a huge thanks to my friend Alex for literally making this project possible. Drop it down in the comments. What do you think we should do with this remote control UTV next? I'm thinking a flamethrower.